live broadcast. Now I'm going to show you how to find out the values of, if you have 0.1 in the circuit and you want to find the equivalent, or you have 0.001, how to find the equivalent. These are true in our circuit, so we're going to discuss both of them. So what you're going to do is, whenever you see numbers like this, you have to know that they are already in microfarads. So 0.1 is in microfarad. 0.001 is also microfarad. All these kind of numberings are in microfarad. When you see something like 101, 102, 100, 103, and so on and so forth, they are in picofarads. Okay, we've given a tutorial on this. So micro is the same as 10 to the power of minus 6. Nanofarad is 10 to the power of minus 9. Picofarads is 10 to the power of minus 12. So when you see numbers like 0.1, you want to write out the unit and then you convert it to picofarads, right? So this is 0.1, right, is the same as 1 times 10 raised to the power minus 1. Once you do this, you want to now convert it to picofarads, because when you do, you can write it as numbers if you're looking for values in numbers like this. So how do I convert this to picofarads? So if I already done this, all I need to do now is to say times 10 raised to picofarad is minus 12. So raised to the power minus 12. Right? But you see, when I move this dot over, when I move it over, so I can write it differently. I can write it differently by saying it's the same thing as 1 times 10 . So instead of writing this, sorry, I didn't put the unit. So when I put the unit, it's going to be minus 7. Yeah, if you put the unit, it's going to be minus 7, because right here you have minus 6 already. Then you move one decimal place, so it goes minus 7. So this is the conversion. Now, I want to convert this to picofarads. So what do I do to make it a picofarad? Not this one here. So let's start afresh. 0.1 times 10 raised to the power minus 6 is the same thing as 1 times 10 raised to the power minus 7. Okay. So you move one more decimal place. Now, this is not standard. 1 times 10 raised to the power minus 7 is not standard. To make it standard, remember that's nano. Nano is minus 9. So if I go 2 more, if I add 2 more, I can get minus 9. So I can say this is the same thing as 1 times 10. Sorry, it's going to be 100 because I want to add 2 zeros. So it's going to be 100 times 10 raised to the power minus 9. This makes it standard. So let's go back. If I want to get to minus 7, I go 1 decimal place, 1 decimal place. All right? So this is what I have now. 100 times 10 raised to the power minus 9. So 100 times 10 raised to the power minus 9 is the same thing as 100 nanofarads. Okay. Now, I want to get this to minus 12. So I need to add, how many more zeros do I need to add to get this to minus 12? So I need to add 3 more zeros. Easily, 3 more zeros. So that's going to be, I have 2 zeros already. So it's going to be 1, 0, 0. These 2 zeros. Then I add 3 more zeros, 0, 0, 0, times 10 raised to the power minus 12, or 100,000 pico. So we run out of space on this piece of paper. Now, I'm gonna get another sheet of paper. But let's just finish it on this side. So 100,000 picofarads. That's what it is, 100,000 picofarads. Now, if you remember, 1, 2, 3, 4, 5. There are 5 zeros here. So I can write this easily as 10 times 10 raised to the power 1, 2, 3, 4, 4 times 10 raised to the power minus 12. Same. And for this, remember the third number is a decimal multiplier. So I can easily just write that this is equal to 10 for 104. Because this location is decimal multiplier. Then I can easily say this is 104 picofarads. All right, so that's how you convert that. So for your 0.01, it's 104 picofarads. For 0.001, it's going to be 102 picofarads. 0.01 is 104, and 0.001 is 102. We're going to do the math too. So I'm going to draw it on it. I'm going to write it on a separate sheet of paper. Maybe we can use this section to do that. So 0.001 is the same thing as, we're just going to go faster here. So just move 1, 2, 3. All right. So it's going to be 1 times 10 raised to the power 1, 2, 3 minus 3 times 10 raised to the power minus 6, because it was in micro. So this means 1 nanofarad. Right? 1 nanofarad. So there, this minus 6 and minus 3 gives you 1 nanofarad. So if you have one that is called 1 nanofarad, use 1 nanofarad, use it. If you don't have one that is called 1 nanofarad, then say 1 times 10 raised to the power minus 9, right? Times 10 raised to the power minus 12 to convert it to pico. All right? So the difference here is 3 zeros, right? 3 zeros. So this one can be 1. If you add 1 0 here, how many more zeros do you need? You need 2 zeros times 10 raised to the power minus 12, or just 102, right? Why do we write 102 here? It's going to be 1, right? The difference between this and these are 3 zeros. But you can't just write 1, 3. There are 3 digits. So you put 1 0, remaining how many zeros? 2. So this 102, you want to convert it back again. It's going to be 10 times 10 raised to the power minus 2. This first 2 times 10 raised to the power minus 12. If you bring them together, it's going to be 10 times 10 raised to the power minus. So this is 2, not minus 2, is 2. So this is going to be 10 times 10 raised to the power minus 10. And then to resolve this, because 10 is not standard, standard is 9 or 12. So to make this 9, you remove 1 here and then you remove 1 there. So it's going to be 1 times 10 raised to the power minus 9. So you're back to 1 nanofarad. All right. We've done a lot of this on our channel, so you can see that. Now to start building our circuit, we're going to use one of these transistors. Today we're going to use 3904, which is this one here. And just believe it, is this one here, 3904. I'm going to give you the pinouts. So when you build something like this, you have a place to put your components. So let's get a fresh one. And these are circuits here. So we're gonna check out the ones we have, so we can go quickly to find all the components. So this one here is 2N3904. We got it. Check it out. We check it off. We're gonna get resistors. 47 kilo. We don't have to be exact. If we don't see it, to save time, we're gonna use another value and we'll just update our circuit. Remember, we're getting 50%, so I don't really, oh, I have 56K, but not enough. I need two of them. $47.7K is 4 is yellow, 7 violet, and then we need the K orange. Okay, I don't see it here, and I can search other places to find one, or I can just update the circuit and use 39K. 39K should be orange, white, and orange, white, and orange. So let's do this. We're gonna take this too. So we're gonna update this circuit to 39K. These are not critical, 39K. All right, we got this too. And then we need 104 and 102. We got it transit 104. Let's find 104. I got 103, but we don't need 103 today. We need 104. And 103 and 100, 501. This one is 501. 104 and 103 are not close. They're an order of magnitude different, so you can just check. Okay, we got 10. Remember, we needed 10. This one is 10. So we're gonna take one of these, but I won't bring it out here first. I'll just take this full thing and put it in our collection. So 10, we got 10. We also need 27, and we haven't forgotten we're looking for 104. This is 104. 104. We need, how many of 104s do we need? Probably need 2 of them. So I have 2 here. So 104, we got this one here, we got that one here. All right. There's 8, we don't need 8. 33, we don't need 33, but we have something close to 33. We had 27, so if we don't see 27, we're going to take 33. Not too far. Not by being too far or being too close, the values we walk into the antenna impedance. 221, we don't need that. 301, we don't need that. 56, 471, we don't need those. 5, we don't need one. 5, 47, we don't need 47. I know I had I have a lot of these things. 202, no. 20, no, we don't need 20. 33, we have another 33, so, okay. 82, 332, we don't need all of that. 3, we don't need 3. 153, we don't need that. 30, we have another 30. Okay, 30 is closer to 27, so we're going to take those ones back. 27, we got 27. So we don't need anything close if we have the exact thing. 15, 121, 7, 22, 22, 101, 68, 75, 153, 2, and 223. 223, we don't need that. Alright. We are getting closer. 473. We don't need this. We don't need 5. 181, we don't need it. 50, we don't need it. 3, we don't need it. 222. We don't need them today for this project. We'll need them for another day. 202, we don't need it today. 602, 40, 18, 2, 121, 333, 424, 72, 141, 152. We don't need all those today. Okay, so do we really have 102 in this workshop today? 472, 47, 82. We don't need these ones. So we just have one more spot to check, which is in this file here. If we don't find it here, then we have to do improvisation for 243, 332, 331, 222, is that correct? 58, 3, 4, 101. It's gonna single digits. I'm gonna confirm. I didn't write that one out properly. Single digit 9, 6 or 9, 6. 683, 821, it's 683, 1. Alright, so we don't have the value we're looking for. Let's go back to our drawing and see what we can update. We are looking for 102. We got 104s. Looking for 102. 102, which is 0.1. 102. What are we gonna do? We need 102. 102. So anything that ends with 2 will be closer. So if we don't see 102, if we see 202, it's close. It's just 0.2 versus 0.1. Or we can try to scavenge from a circuit. So let's try to scavenge. But it's totally strange that we don't have 102. Okay, you know what? We're gonna look for something close to 102. Have my 104, have my 10, and where's my 27? Have my 27. So let's find something close to 102. We have 103, we don't need that. Um, you know that 6682 is closer to 102 versus 103 because this only means 0.68 or 0.7. Meanwhile, 103 is a whole order of magnitude, which is 1 nano. What? No, 103 is times 10 raised to power 3 times 10 raised to minus 3 minus 12, which is 10 times 10 raised to power minus, which is 10 nano, 10 nano. And we're looking for 1 nano. We're looking for single digit nano and not double digit nano. So I'm gonna keep this 682 closer. It won't be exact, but it'll be closer. So I'm looking for things that end in 2. If this is 202, we're gonna use it because I have to just verify. No, it's not 202, it's 203. Let's write it out better. 203. Alright, so let's look for everything that ends in 2, especially if it's single digit 2, which means single digit nano, which means there's going to be 0 in the middle. 221, no? I see 10 something. Is this 102? Let's use our telescope. I think this is 102. That's the Lucy 102. We're gonna confirm it. We're gonna confirm it, and then we're gonna write it out better. To confirm that, we're gonna use our telescope, microscope. Sorry, use our microscope to verify that. This microscope stopped showing my video. Okay, let's go. Power on. Alright, let's get it on this mask. Let's get one out. I would have preferred a ceramic capacitor here, to be frank. It does good with power filtering, but yeah, that's 102. So we got our 102. Right. And I think it's also written on the bag. There's 2 magnified. can see that. 102. All right, so we've proven what we want to prove. We got 102. Just write it clearly on the bag. We need a marker, but pen can do for now. All right, so we got our 102. Putting it back in the bag. No, we've lost it. We've lost 102, but we still have some, so we're gonna use these ones. We have to find it because we don't like losing components, especially when they are few. But let's find that at a later time. All right, so we got. Let's get this off because we're done with it. It says goodbye. We're done with the microscope. So let's see what we've got. We got 102, which is this guy. Now we need 220. 220 microfarads. Where can we find it? What's our collection of capacitors? All right, let's see what we have here. For 7 microfarads is not. Hundred microfarads not big enough. We're looking for 220 and 470. 47, another 47, and I don't think any of this will be big enough. 100, 47, 33, 0.1, 2.2. So none of these is big enough. Let's check these ones here. Let's check these two values. Both of them are the same 33. Right, and we don't have enough. We have enough pass. 470. Oh, yeah. We got this one. 470. Alright, so we got 470, which is this guy here. And we need point. Okay, we got 0.1. Okay, we actually needed 2.1, so we got two of them. Yeah. And then we need 5 ohms. Okay, let's get this resistor here. We have it easily. We have this 1K. So we're gonna go to the pile. and look for the values. So we're looking for 1K, 102 is 1K. So this guy is 102. So that's 1K. We're gonna get it. You can see the value is 102. 102 just means the first digit is 1, second digit is 0, third digit is 2, which is 10 times 10 raised to the power 2, which is 1000, which is 1K. So we'll get this 1K here. And then we need this one here. We haven't stated a value. We can use 5K for that, just to distinguish. We can make it 5K. It's our choice what we want it to be. So we're gonna find 5K. 5K is gonna be 502. I think we got it before. We're gonna remove this one because we're no longer looking for it. So let me write this out. So it's easy next time. 102 to find. This is 104. One zero one. Two zero three. That's 20K. 503. That's 50K. 502. 502 is 5K. So to make it easy for ourselves, we're just gonna call this one 5K. We're gonna say we got it. Now we need this diode. This is a different diode, but if we don't find the one we're looking for, we can consider it. We check the spec and see if we can use that. Okay, we found the one we're looking for. There's no need to look for equivalent anymore. All right, so we just need one of them. All right, so we got the diode. Now let's see if any of these capacitors can serve. This is 470. We got one. So we have two 470s now. So if we don't find 220, we're gonna use 470 then. This one also is 470, so we got a lot of 470s. And we got this 100. Okay, so we're not gonna use the 100. We'll see. Another 100 we're not gonna use. Four seventy. I have lots of 470s. We have lots of 470s. This might also be another 470. 100, not 470. All right. Okay, I don't like losing components. All right. What's this one here? Yeah. So we're gonna change this value to either 100 or 470. Okay, I'm gonna use 100. Let's just do 100 here. We're gonna use 100. Get that 100 back. Let's see the value. We don't need 470. We need 100. We need 100. So we're gonna use this 100. All right, so we got 100 here. What is missing now? This variable capacitor, we have lots of it, and we're gonna make it a card. So let's get a variable capacitor. And look, we even have lots of capacitors here. We didn't even consider any of them. Okay, they didn't qualify. All right, so let's get variable capacitor. Where is it? Let's get a variable capacitor. So this one here. This one is 40 picofarads. And this one is 5 picofarads. And this one, I don't know the number, then the brown. I think we have more piles of these. We have more piles of these. So let's see what we're gonna do. One, two, three. All right, let's just use 40 picofarads because our range is 5 to 45. If I use 40 picofarads, should it should cover. We already got one before. Yeah, this one is 50 picofarads. This guy is 10. So we're not gonna take 70, maybe 70. So we're not gonna do this. Now these two look alike. And then 50, we're not gonna do 50. Let's just do 40. I like the yellow. Okay, let's just do that. Let's do that. Remember, it's variable, so the value will change as we turn it around. We'll take one new component. And I'm going to put the rest back. Remember, we lost a capacitor. We're going to go look for it. We don't like losing stuff. But we won't look for it now. We're going to make an inductor. We're going to find the right wire. So we're going to arrange some coils and we'll find the right one for us. Alright. So this is very fine. So we can use this for maybe when we need longer coils, like when we build AM radio receiver, we can use this. All this, they are fine. This we can use for this kind of transmitter. This one here, and the wire is, I think it's sturdy. We can just wind it and it will take the shape and stay. But today we're gonna use this one here. It's the thickest of the coils we have, and we want to use that. Watch our tutorial on inductors to understand the impact of the diameters, the length of the wire used, the cross-sectional area of the wire, number of turns, the length of magnetic circuit. So I'm going to look for a 5mm core, something I'm going to wind this on. So I'm going to look for my caliper. All right. We're going to use a caliper to measure the diameter. So first of all, we're going to zero it out. This is 7mm. 7.3 is bigger than what I want. So I'm going to look for something closer. Alright, so we're going to try these things here. They're 3 bits. They can do multiple things for us. So this is close. 4.75mm. We can use that, but I'm going to try, see if I'm going to find a bigger one. Another 4.75. 5.5 is bigger than we want. All right, we have two more. We're gonna try these two. If we don't get what we want, we're gonna like what we get. 5.5 bigger than we want. This is 5. That's what we want, 5. All right. All right, we were observing a place for everything and everything in its place. All right, so I'm gonna get 5 turns here. We said 4 to 5, so 1, 2, 3, 4, 2, 4. Okay, let's make it 5. Remember, we could use the fixed inductor, but we just decided not to right now. So this is an inductor. We decided not to because that fixed inductor, we could use it for a filter network that requires 2 identical inductors. And when you do it manually like this, you might not know exactly the inductance. Right, so this is our inductor. All right. So I'm just gonna put away the coils because they've served their purpose. All right. So we're gonna put everything in their place. All right, so the next thing now is to start assembling the components on the board and start soldering them together, which I think should be easy. Gonna get all the wires out of the way because this can get very hot very soon, and it doesn't take prisoners. If it gets you, you will know. So let's get all the wires out of the way. We need our soldering light. All right, so let's fix the inductor first. We have to scrape the ends. We're gonna expose the wires with scraping the enamels. And then we have to just, I'm gonna turn the soldering iron on. Another easier way to scrape the ends is to use sandpaper. And to be sure they're exposed, I'm gonna just use continuity meter, or maybe we can use our inductor. We may not be able to measure anything because inductance will be very small. But we'll see. None of this works. We're gonna see. So let's just try inductance meter. Gonna fire the inductance meter on. What an error. I say this takes no prisoners, and I think I perceived an odor, which means one of the wires touched the soldering lead. It's already burnt. The soldering iron, sorry. It's already burnt. I could perceive the smell. Yeah, I have to be very careful. I could already perceive the smell. Yeah, the value is too small to be seen, to be read. Yeah, but at least the wire is exposed, that we can confirm. Alright, let's be careful around these. Take note, prisoner soldering iron. Alright, we are not happy with this burning our, oh dear. Wire. Alright, let's start the assembly, shall we? Alright, we're gonna get our base here. Then we're gonna assemble according to the circuit that we've drawn. Transistor. Transistor is the terminals is emitter, the center is base, and the end is collector. So it's emitter, base, collector if the transistor is facing you, if the number is facing you. So we're gonna insert it. So like we said last week, we're gonna leave this portion. I'm gonna start from here. So I'm gonna bias myself forward a little bit. Okay, let's switch this iron off, because it heats up quickly, so there's no point leaving it on for a long time. So this is in here. I'm just gonna bend one of the pins only, leave the other two standing. I'm bending the one so it doesn't fall off. Then I'm gonna put the two resistors. I connect the two resistors. Right, the two resistors are in. Bend the outer pins. All right, and then I'm gonna put my capacitor, the 104. So I have 104 in, and I'm gonna have I'm gonna add 1K. I think we missed one component, which is the 75. I'm gonna add the signal diode first. 470. Right, 470 is in. I need that 75 ohms. And then we have to put the 27. Where's 27? Then the 10. Right, that's the 10. Alright, so I've added a 10. I'm gonna add the capacitor variable cap. And I'm gonna add the inductor. Okay, we've lost the inductor. So we'll find it or we'll make another one. Okay, this is not expected. It was right here. That's why we made all the components, arranged all the components before we started. But things happen. Alright, let's just add the 100. That goes from positive to ground. Right. And that's going to be in parallel with 102, which is 0.1. I'm going to get the 102. just cited the coil, the inductor. It fell off the table into the drawer. Okay,